Hi, welcome to Digital Dialogs, your compact conversations on the future of technology. My name is Renee from Reply, and today we're going to explore elevating touch, the future of haptic interfaces in virtual and robotics interaction, which is a really awesome topic actually to talk about. And I'm very gladful to have a special expert guest today, Professor Katherine Kuchenbecker. Hi, Katherine. How are you today?
I'm great, Renee. Thanks so much for having me.
Awesome. We're very glad to have you today because, like, of course, haptics and touch and the whole kind of tactile sensing and so on is a super important topic that needs to be added to robotic solutions. But we will talk a little bit more later about these in detail. First of all, Catherine, please introduce yourself to our audience. Tell us a little bit about your journey, how you got into this field, what inspired you, what you're doing right now, and all of the good stuff.
Yeah, I'd like to start at the beginning. I was actually born in Los Angeles. Although my name sounds German, I'm American. My mom is a research psychologist, so a professor, and my dad is a surgeon. And I always loved technology, like science and math, but I also love languages and writing and art. And I was lucky to study at Stanford University in Northern California. I got my bachelor's, master's, and PhD all there in mechanical engineering. And I think that's actually really important because touch is about mechanical interaction. So having like a fundamental understanding of how things physically interact is really useful. But I was always interested also in electronics and sensors and actuators, motors, robots, and software, computer science. So I did a lot of mechatronics and human computer interaction. So I was always very interdisciplinary. And I found through when I was doing my research and also working in the machine shop at Stanford, where I used to help students design and build things, that I loved working with students and helping them learn and do projects. And so I decided I wanted to become a professor. And I was for 10 years a professor at the University of Pennsylvania in Philadelphia on the east coast of the US, which has a wonderful robotics lab called the GRASP Robotics Lab, which is very interdisciplinary. And then in 2017, I moved to Germany, to Stuttgart, where I'm a director at the Max Planck Institute for Intelligent Systems. And I lead a team here called Haptic Intelligence, and we work on all kinds of research related to the sense of touch for humans and robots.
Well, that's an amazing journey, and also I love your diverse background that you explained. So thanks for giving us your background. That is really impressive, in fact. But let's talk a little bit more about your recent work in the Max Planck, but also in general on your work on haptics. And so, first of all, can you provide an overview of the work, your work, and your team's work in haptic feedback and dynamic tactile cues? And maybe you can also explain how these approaches enable more realistic interactions, also in teleoperations, virtual environments, all of that. And I think you also have this cute wearable device that you're working on. So maybe you can use that as an example. But yeah, give us the download on that section.
Yeah, I'm happy to do my best, and please jump in or ask for clarification if anything I say doesn't make sense. We all have good experience with seeing videos or hearing recordings. So humans have pretty well mastered recording visual and audio, so sight and sound, but the sense of touch is much more complicated than either of those. And you can think about it because your eyes are concentrated only in one area of your body, and your ears also have only a very small sensory um, area. And so to engineer a camera or to engineer a microphone, of course, that was years, thousands of people, thousands of papers were required to master visual and audio recording and also replay. But touch, we're still in relatively early days comparatively because touch is distributed through your entire body. It's not just one kind of sensation. Your skin, it's your largest organ, and you can measure, you can feel different things in different places. So, for example, you can definitely tell where things touch your body, if they're sharp or soft, if they're moving across your skin, if they're pushing in. You can feel pain. You can feel temperature if your skin is warming up or cooling down. You can feel vibrations. It's a common, people often like kind of think like their skin is like their eyes, like their retina, but it actually is really different because of this distributed nature and it's mechanical. And so we only feel like you can look at the world or hear the world without affecting it. You don't have to change the world to observe it, to see or hear. But to touch, to feel something, you have to move. You have to bring your body into contact with, say, we have a strawberry sitting on the table, or a pair of scissors, or a wine glass. And you have to reach out and choose what part of your body to touch it, and then process how the contact changes your skin. And so those are, because it's so distributed and also has so many different facets. Actually, you can feel vibrations
Hmm.
up to 1,000 cycles in a second. So if you kind of try to move your hand back and forth, you can maybe move it back and forth only 2 or 3 times in a second, but you can feel 1,000 cycles. So
Wow.
if two things, like if I clap my hands or
Yeah.
if I hit the tools together, those vibrations are also feelable in your skin. So there's this rich flood of haptic information that your body is constantly getting and using to make sense of the contacts that you're doing. And then, so now there's two sides that I work on. On one side, we're trying to create those kinds of haptic sensations for you, a user, when,
Hmm.
let's say, you're interacting with a virtual environment, or you're controlling a robot remotely, maybe to do surgery or to control a construction robot. And so, whether it's a virtual or remote interaction, we need to give the robot. So we need to. There's the sensing part, but let me explain. Sorry.
Yeah.
When you're the human controlling, interacting with, say, virtual world, maybe you're reaching out to type on a keyboard or shopping online. We need to create these haptic sensations for you to feel. And that means we need actuators, motors, and they tend to be big and expensive and hard and bulky and just not something you would want on your body. So, actuation is a big area that we work in.
Hmm.
And that will lead right into the CUTE device, our cutaneous electrohydraulic actuation. Another aspect that's really important is the timing. So, let's say you reach out to grab this virtual strawberry, and you're expecting to feel something on your fingertips, not before you touch it visually and not after, but the timing has to be just right. And that's actually how your brain connects something you feel physically with with your actions, and what you see is the timing. And so we need actuators that can react quickly. And like cameras, videos, you only need to present about 24 or 30 pictures in 1 second for it to look smooth. But we actually need to update the haptic commands much faster than that, maybe 1,000 times a second, so that it feels smooth and happens quickly and doesn't feel delayed and wrong. So, what would you want me to go into more detail about? Maybe about haptic actuation for human users? Would that sound like a
Yeah.
good thing?
Yeah, absolutely. Maybe you can dive a little bit into this. And also, I would also be interested in hearing about your collaboration you're doing also with clinicians and multidisciplinary teams that kind of also drive some of the development in these haptic interface for medical training and so on, because I think that's also an important aspect. But yeah, talk about it, please.
Yeah, yeah. It's actually really key that we collaborate with other people. I'll come back to that as soon as I finish explaining. So,
Yeah.
as I mentioned, I think actuation, how to take a signal from a computer or phone or something and create a physical movement in the world, like how do we transform that digital signal into physical motion? Currently, all the devices you have are only able to output vibrations. And they do that in a couple different ways. The most common approach is what's called an eccentric rotating mass motor, where there's like a little motor that can spin pretty fast, and it has a mass off on one side, kind of like the clothes in your washing machine off center, and it jiggles when the washing
Yes.
machine is spinning fast. But that's not very natural. It's kind of annoying. So it's good at getting your attention, but it doesn't feel like it doesn't feel like I cut fabric and like or I drag my fingers over a knitted garment. Those are pretty artificial vibrations, and because they're the bigger they get, the faster they go, and they just are really strong and annoying. And so, a huge goal of my research has been how can we create actuators that can create a much broader range of haptic sensations and also that feel nice, that people are going to want to have these sensations, say in a wearable, in a watch. And always before, I'm a mechanical engineer, so I understand uh, electromagnetic. We can make a coil of wire, we can make a magnet, then we pass current through the coil, makes a magnetic field. We can make forces back and forth. We can change that like a speaker. We can basically take speaker audio technology and adapt it to make haptic sensations pretty well, but it ends up not working very well for mobile devices because you have these rigid, like you don't want to wear these big, bulky, rigid things that get hot and that
Yeah.
take a lot of current that draws your battery down so fast. It's totally unfeasible. And so for years, we were searching for a new solution. And I'm lucky I was able to help hire a new director here at my institute. His name is Christoph Keplinger. He's Austrian originally, and he's an expert on artificial muscles, basically soft, new ways to make movement happen in the physical world. And the approach his team pioneered in starting in 2018, when he was a professor at the University of Colorado Boulder in the US, is called Hazel actuators. And we have adapted this. He and I have a PhD student together, Natalia Sanchez Tamayo, and she worked jointly with both of us to adapt these artificial muscles, which have previously maybe been used to make a robot leg, to
Mhm.
make something really small that could just fit inside of like an Apple Watch or a small wearable. And instead of only vibrating, it was really important to us that we could, it starts off of your skin just a little bit, and then it can move several millimeters, and it can make and break contact with you. So imagine, Renee, that I could reach out and touch your hand, or comfort you by touching your shoulder, or poke you to get your attention.
Yeah.
This like starting and ending of contact is very common in interactions between people,
Yeah.
but it's totally been missing from digital interactions. And because we use, they're basically, it's like a plastic bag filled with oil. So imagine just like a Ziploc bag or plastic bag that you would have at home. Literally, you fill it with oil, and we've printed some electrodes, some like silver ink on the two sides. And then when we apply a voltage, like an electrical voltage between the two sides attract together and they move the oil out to the other side. And that,
Mhm.
in a similar way to how your muscles can extend, can contract, that allows us to make these little pouches extend and they can then move and make contact with your skin and actually push pretty hard, like 2 or 3 newtons, so maybe the weight of a couple apples, which is for a tiny little package, really a lot of force. But it also feels nice because the materials are soft. And beyond that, we're not limited to only slow actuation. I mentioned before that our skin can feel really high frequencies, and we can also, similar to speakers, we can drive them with really fast signals of all kinds of sensations and basically create. It's kind of like red, green, and blue pixels that you see on a screen, but here we're now doing it on your skin, and we can make and break contact, press, and vibrate. We have this new vocabulary for digital devices, and that's what we call the cute device, cutaneous for skin, electrohydraulic because it uses electricity to hydraulically push the oil around. Do you have any questions about that?
That's pretty awesome, actually. So, like you're saying, your basic, it's like hydroelectric. Yeah, I mean
Actually,
that
electrohydraulic, not hydroelectric, but they
yes,
have the same words.
yeah,
We start with, yeah, instead of hydroelectric is like a dam that starts with
yeah,
water and turns in electrical energy,
yeah.
and we're starting with electrical energy and using hydraulic pressure to do the mechanical amplification.
That's pretty amazing. So, how can you miniaturize it, and how would you like make it practical, like you're saying, or maybe on a mobile phone? Would you basically make the back of the phone out of this material, or how would that work actually? How would you transport the sensation?
You're asking so many good questions. It takes years of fundamental research to figure out things like this. So, just figuring out how to make such an actuator and then to characterize it to show how well, figure out how to fabricate it and that they will last and do physical experiments and then also have people test it and show they can really well recognize the signals, maybe do some adaptations. That's like one PhD student, like 4 or 5 years
Sure.
of,
Of course, yes, yes.
yeah.
It's a big team.
And actually, there's still some remaining challenges as well with we need high voltages, very, very low currents, but higher voltages than are normally used in portable electronic devices. And so that's another effort. Actually, Jonathan Feeney, who happens to be my husband, he also went to Stanford and he works here in our institute. He's doing a lot with both Christoph and me to do high voltage compact electronics to enable devices like this. Specifically, I'm actually for a wearable, we are envisioning it something that's pressing on your skin. But for a mobile device, we're actually more thinking the actuators could eventually be on the screen themselves, so on the front side. But there we have to then make them transparent so they don't mess up the view. So imagine you're looking at your screen and you go to type or push a button. Instead of only feeling the whole screen vibrate, we envision a future where you could actually feel buttons at different locations on the screen. But this is very technically challenging because the actuators have to be very, very thin and also clear, like transparent. So that's something we're thinking about, but we don't have any publications yet. The Qt device, the wrist wearable, that we published in December of 2024 in a journal named Advanced Science, and
Mhm.
we've also done a fingertip wearable, more for like virtual reality to reach out and touch things with the fingertips. We need to work more on making the devices robust and making the electronics like portable, not needing like a box on the table, but something that could be integrated into the device. But I think we're going in a good direction. We always need a lot of creative experiments. It's really important that we not only have a diverse team, like people coming from different backgrounds, because if you've been studying human computer interaction your whole life or
Yeah.
material science, you have totally different ideas of what
Mhm.
would go into a paper. And often it's by having several different experts, people coming from different disciplines, where we can tell a whole story and not accidentally make something that is incomplete and has like an Achilles heel, like a big problem. Like
Yeah.
we have to look at it from all directions, just like the people who will read the paper eventually will come from all different backgrounds. But if we build a team from the beginning that has many different kinds of expertise, then we can kind of guide the project in a more fruitful way. And then I think also we test with people, like we bring volunteers into our lab and have them try to give them. I always feel like I have to take off my hat of the engineer, where I designed and built this thing. I love it. It's my baby. We're so proud of it.
Yeah.
We have to completely set our love for the device, the system aside, and bring on our scientific, like, now my job is to find out what people think of this thing. Does it work? How does it work? What's their intuition? The user is never wrong. They, whatever they expect or they think they are disappointed, whatever expectations they bring to the interaction, whatever they find delightful or frustrating, we have to kind of accept that and incorporate it and integrate it into the next iteration. So that's obviously, it's just really, really fun. It's always very stressful to bring random people into the lab and have them try to do different tasks, but it's really a fundamental part of our process.
Yeah. Speaking of the collaborations, and I fully agree, like you're saying, like having like a team with diverse background, diverse training, and just a different also culture brings in so much better
Mm-hmm.
solutions. Like that's a huge important aspect. I fully agree with that. And also you mentioned that you're like coming back to the multidisciplinary team question, and also working with clinicians. What challenges have you encountered when dealing with medical training and haptic interfaces when you have to basically make these practical? You mentioned, of course, the miniaturization. There's a bunch of these aspects, but maybe also cultural shift and these kind of aspects. You can.
There are many challenges here. I'm really, really lucky that my father is a surgeon. So I grew up, my dad would bring home videos of surgeries that we would watch. So
Really? Oh,
my
yeah.
sister, my
Oh,
sister's also a
I brought
doctor.
home some good videos from Blockbuster, but actually not from Blockbuster. These are from my work. Look at this. Here I'm opening a chest.
Actually, my dad was one of the first surgeons in the U.S. or early adopters of laparoscopic surgery, minimally invasive surgery, and he always said that all of his past background playing video games really helped him do. It's like surgery through these long, thin tools where you have to
Yes.
look
Yeah.
at a 2D screen and figure out how to move your. He's really good at this. So is my sister. I'm not sure it's because he played video games. I think he has good eye-hand coordination and understands anatomy well.
Yeah.
But I really enjoy working with clinicians, and I want my team to work all the way from the fundamental new inventions all the way to applications. Um, but it takes time. You have to build relationships and trust, and also understand where they're coming from, like what their motivations are, and An early invention that I'm really, really proud of was how to add haptic feedback to robotic surgery systems like a Da Vinci robot.
Hmm.
And our
Oh
solution
yeah.
was really, really simple, just adding accelerometers, tiny little vibration sensors on the robot arms. And then no matter which instrument the surgeon's operating on with, we can measure these impacts and contacts, which are complementary to what you see because you can't see
Yes.
them. They're looking at a camera, but if their two instruments hit or something hits the robot out of the camera view or they cut something, we could let them feel. It's almost like a microphone and a speaker, a haptic microphone and speaker for your left and right hands. And it worked so well once we figured out a few tricky things. And I had a wonderful surgeon, Dr. David Lee at Penn. He was a urological surgeon who was doing like 10 to 15 robotic prostatectomies a week. He's now at Irvine in California. And he let my team come in and watch surgery, talk to us, tested prototypes late at night and like testing in the operating room, helping give us feedback about what would work and what couldn't work. In the end, I tried to commercialize this technology, but it was never successful because financially there wasn't like a good business model. It's still something I would love the future surgical robots to have the kind of haptic feedback that we invented, but it we couldn't you couldn't let it wouldn't enable a surgeon to do operations procedures they couldn't do without it because they are so well trained and they can see very well and they've like learned how to use a robot where they're remote controlling these instruments without any haptic feedback, that like changing a medical device, something that's used in the operating room in such high consequences settings, you have to really enable a leap forward. And so to let the doctor deliver substantially better care to justify the cost and complexity of changing the technology. And so in the end, I failed or so far have not succeeded at commercializing that. But aspects of that idea still um, come back into other areas. So we actually adapted that for construction robotics, and I hope it could someday also be useful in construction. And it also has informed a lot of our work on surgical skill and training, which is less regulated, easier than changing the technology a doctor is using in the actual operating room compared
Hmm.
to how they prepare the day before. That if we can help them learn more efficiently by, say, shortening their learning curve, letting them practice, say, with haptic feedback, the kind of haptic feedback we invented, and that lets them do procedures sooner, safer, because they just understand how powerful the robot is, and they can learn more quickly to guess about what the contexts are because they've been able to feel it when they're practicing just on like practice materials, not on a human. So that's another way that we can bring the technology forward. So you have to stay flexible. You can't
Yeah.
focus only on one path. You have to keep open and sometimes realize you shouldn't go in the front door, go in the back door, like, or go in the window, or you have to stay flexible and look for any way to make a contribution
Yeah. Yeah.
and where the idea might come.
Makes a lot of sense. It's like I think the biggest aspect is really being agile and not getting let down by maybe the, I don't know, some no sayers or something, but like trying to find other paths. Makes a lot of sense, and I fully agree. And I'm sure also your background with your family and in the medical field is helping a lot also. So it's a different culture as well, right? Like when we're dealing with like technology folks like us, it's like a lot of us
Yeah,
are
even when you both speak English, it's a different language. One saying that really helped me, I had spent a lot of time with the product design community at Stanford, and then later with the integrated product design, so like community at Penn, and they say if you want to have a good idea, have a lot of ideas,
yeah.
and you can't expect any one idea to be good, and you have to. So I also had interned at IDEO, which is a great design consulting firm in the Bay Area in California, and they had these 7 rules of brainstorming, like go for quantity, be visual, write them all
Mm,
down, build on the ideas of others, and defer judgment. Like just encourage creativity, come up with all the ideas, encourage crazy ideas, and then sit and think, which of these could actually work? And
yeah,
that's how you can find new pathways, even when one direction doesn't seem to move forward.
yeah, yeah. Absolutely. And maybe last one, last question for you is again maybe use your crystal ball a little bit. I mean, we already alluded like what are some of the challenges, but also what are some of the opportunities you're seeing in the future that will help your field to move forward. Maybe if we look at recent developments in generative AI or humanoid robotics, there's a lot of push right now in the field. also when it comes to miniaturization and other aspects. But in general, also big tech companies are investing a lot money right now into these fields. And obviously, although we're talking about, also human, feeling, sensation, feeling haptics, but the other thing is also, we got to give robotic devices, tactile sensing, and so on. So my question is, like, what do you see as maybe challenges, but also opportunities ahead of us, especially when we look at the recent developments in the technology? Yeah, maybe you can talk a little bit about that.
Yeah, it's actually a really exciting time to be in robotics and specifically working in haptics and touch technology. I was at in September last year in Rotterdam. We had a 40th celebration of this big international conference, ICRA, and there were like 80 or so keynote talks. I gave one of them, and I was amazed at how many of the keynote speakers mentioned touch and haptics, even people who haven't been working on touch in the past, because maybe before robots were driving around and looking at the world, mapping an environment, but as soon as you want to do something more than just build a map and see, you want to move something, you want to close a valve, you want to help help a person, you want to build a building, you want to put away the dishes, you need to reach out and touch things. And the way robots were built in the past were very precise and rigid, a little bit dangerous, and people would stay around them, away from them. Sorry, keep people away from, say, in a factory where robots are very efficient and doing repetitive tasks. When we want robots to now be able to come into the human world, which is unstructured and messy, and physically pick up objects or move them around or help people do things, the sense of touch becomes incredibly important. And robots, in the same way that we need to bring touch sensations to a human user in virtual reality or remote controlling a robot, we need to give robots a sense of touch. And they today really have almost no touch sensing, and that gives them a huge like blind spot. That means robots can learn physical tasks, but what is often not visible or apparent when you watch a video of a robot like manipulating a Rubik's cube or something, what's happened in the background of like thousands and thousands and thousands of repetitions, first in simulation, so like a
Yeah.
robot hand basically playing with this physical object, and then also on the real hardware, and only with vision. And we know from our research with people that when you have people operate only with vision, say in robotic surgery, it's very cognitively demanding because your brain is having to process images and figure out when contact starts and ends and how hard are you pushing. We know also if you take away a human sense of touch, if you anesthetize or make your fingers numb, you probably know this, if your fingers if your hand ever falls asleep or your tongue or lips are numb from the dentist, you can't move very well because
Yeah.
there's such a tight loop between your sense of touch, whether contact is happening, and your movement. And so we know it's very cognitively demanding on humans to do things without touch, explicit touch sensing. And the same is true for robots. And so right now we're just paying that cost in pre-training and computer and processing all these images and just burning energy to train an algorithm and to do, I think, to do manipulation and physical interaction tasks more efficiently. Robots are going to need a sense of touch. And that has many of the same challenges
Mhm.
of distributed actuation, like the soft actuation I was talking about, but for sensing. So basically being able to make something very thin, but across a robot's skin that's soft and that can sense where contact's happening and how things are touching a robot. So we're working on some like robot fingertip sensors and robot skin as well.
Wow, that's some impressive research, and I'm sure once these things will all come together, I expect, I keep on making the joke that I'm pretty sure that by the 2030s we will see humanoid robots in a lot of fields working, maybe in factories and maybe even in some places. But here in Germany, we will our authorities, some of them will still use fax machines at the same time, right? So
Well, we're
maybe
going to need a humanoid robot to
uh,
operate the fax machine, I
exactly.
think. And it's going to need a sense of touch so it can push the buttons to dial and pick up the pieces of paper of the fax, the incoming fax.
Yeah, yeah. Now finally we're closing the loop here. So that's why we're all working on this actually. But no, joke aside, it's really really incredible work, and you're of course you're laying the groundwork, right? Working at the MPI, the Max Planck, you're building the foundations, and then like more applied science takes it up, or companies take this up and commercialize it. But the groundwork that is being built by your lab and your team is really amazing, and I encourage like the audience here to check it out also on the website and some of the publications that are available. highly insightful.
Thank you so much, Renee. It's really a pleasure to talk to you about this. Thanks for giving me the opportunity. I'm really grateful for the wonderful team members that I have that come from all over the world. I'm grateful for Germany welcoming these international young scientists who bring their creative ideas, and that the Max Planck Society gives us the support to do this basic research so that we can try to discover new things that can launch, hopefully, new industries and improve the technologies we're all using every day.
Thank you so much, Katherine, for joining us today. It was so insightful, and like I said, I really appreciate the work you're doing. That's awesome stuff, really.
My pleasure. We're going to keep working hard and try to figure some new things out. So stay tuned.
Awesome, awesome. Well, and thanks everyone for tuning in to Digital Dialogues, your compact conversations on the future of tech. Don't forget to subscribe to our blog, and of course, most importantly, subscribe to our podcast channel on your favorite podcast platform you can imagine. Just search for Digital Dialogues Reply and you can find us there. And of course, on reply.com, you can also find all the previous episodes and the upcoming ones. Until then, take care and see you soon. Bye bye.